So we are now on dynamics. Managid tanaw sa atong review sa statics. So karon pa kita mag-start for dynamics. Ato utilize ato ang uh, 1 month and I think 2 weeks, 1 month and 2 weeks, no, for this semester. So let's start our discussion for dynamics regarding the basic principles behind this branch of mechanics. So let's start with the first lesson. We're going to talk about those general principles that are common to this subject or to this branch in dynamics. So by the end of this lesson, you will be able to understand the evolution of dynamics, where did it begin, no? Or shall we say the history of dynamics. Second is you will be able to differentiate between particle and body. So there's a huge difference between a particle and the body when used in dynamics. And finally, you will be able to differentiate kinematics with kinetics. So when we talk about dynamics, it is mainly a study of the motion of an object. So this is very opposite, no? Opposite with statics, because in our statics, we study object in stationary mode, no, in a stationary condition. That is why during our review, so we have solved problems, no, that involve structures, and then we solve the resultant forces or the unknown forces. So those forces are static, but here we are dealing with objects that are in motion. So dynamics gives us a vivid description of the motion. So how are we going to describe its motion? So through these parameters. These are the common parameters, no, perminti gid na to masugatan sa dynamics. We have the displacement, velocity, and the applied force. With this, we can quantify, no, the motion of an object, like asa na siya, and then how fast is it moving, and where does it moves. Okay, and of course these parameters are with respect to time. So time here is very important. Now, why do we need to study this one? So as you can see in the figure on the left, so this is an intercontinental ballistic missile. We all know that we are now at war, no? And then a lot of countries are conducting research and development with regards to weaponry. So the science behind this one, no, in order for them to predict the target of this kind of weapon, so they are using this fundamental principle of projectile motion, because uh, most of our weapons, no, kanang ato missile or even kanang balastong pusil, it does not travel in a straight line. So pa-curve gina siya due to the influence of gravity. Now, to track its motion, we need this principle. And this projectile motion is under dynamics. Second application that we can see in our surrounding, of course, we have machines. This is very related in our field. So these are gear sets that can be found inside our vehicles. So with the principle of rotational motion, we can examine the rotational the rotational speed of the shaft relative to the other. Okay, so we can predict that the speed reduction, no, of this one is, let's say, from 3 rpm to 2 rpm. So by using this principle, we can predict the speed reduction, and also we can predict the speed of the gears that are connected to a certain shaft. And finally, with dynamics, So one of its subtopics is the impulse and momentum. With this principle, we can investigate a car collision incident, no? Atong makuan kung kinsay sad-an, no? Or kinsay nag-overspeeding. So, muna siya ang applications for dynamics. So that is why we really need to study this branch of mechanics. So this one, dynamics is actually um, new pa lang, no? Um, compared sa statics. So it began on the 15th century during Galileo's time. Tapos, ang iya pong development was retarded. The first reason is ang lack of the availability of precise measuring instruments for time. So, ang measuring instrument is still underdeveloped, although there are some kanang instruments nga na-made na like the pendulum, but of course prone to error gihapon and still contains a lot of improvement, no? So dili pa gid accurate, and mao na to ang giing kaganiha, the three parameters, very important parameters in dynamics, rely on the time. So if wala tay accurate nga pag-measure sa time, then those three parameters will also be inaccurate. So mo na siya nakapa-slow pod sa development of dynamics. And of course, the natural philosophy, the principles of natural philosophy. So it also contributes the development of this one, because we all know that in our history, natural philosophy and science sometimes contradict. One good example is the claim of Aristotle. Mo na siya naka-change sa fate of dynamics. Si Aristotle sa una, claim siya nga if heavy gayang object, no? So mo fall siya faster than the light ones. So ingon siya nga if nakay bola, no, nakay bulitas o nakay let's say kanang papel, ihog na nimo sa lagdungan, of course ingon si Aristotle, very common sense that the the bulitas mo fall faster than the paper. Okay, mo na iyahang claim. However, it was contradicted by Galileo, no? Kung naka-remember po mo ano yung experiment on the Leaning Tower of Pisa. Diri yagi claim nga all things fall at the same rate. So, dili siya nag-disregard siya sa weight of an object, iya composition. So, fall at the same rate. Now, this one, wala ni no, nagloading ani ang tao sa una. Syempre, kay ang ato gid na-observe is kay Aristotle nga very common sense nga bitaw mura bitag mag-una ang bugat. Now mag-una lang to siya, it's because ang free fall man god, ang science behind it one is very complex. You need to know the principles of drag and air resistance. Now, with the kanang advent of modern technology, no, na-prove ni siya nga sakto gyud si Galileo og sayop ang claim ni Aristotle. Kay kung maghug ka og hammer og feather ngadto sa moon kay walay air, so there is no friction, there's no drag, no air resistance. So magdungan og kahug ang hammer og ang kanang feather. Remember, hammer is heavier than feather, no? So dungan gid sila. And with that, so iya gid nakuan nga ang pag-fall sa object, no, ang ilang acceleration, ilang rate is constant, and that is equal to g in the later development of dynamics. And si Newton pod, no, kani siya, this is very famous on his three laws of motion. He agreed with Galileo and he developed the later principles of dynamics. Okay, so foundation ani kay Galileo, no, iya gi-correct ang principles of natural philosophy. Dugay kani siya, so napriso pa ni siya maong hinay ang pag-develop ani nga branch of mechanics. Let's proceed to particle versus body. Now, in dealing with dynamics class, of course, we need to have a subject of interest, no? And we call that one as the object. Okay? So sa picture ang ipakita ganiha, we have the ICBM. So ang object na dito is katong missile, ang mga car collisions, ang object na dito kay ang mga sakyanan. So importante gyud na object. Of course, we cannot tell a motion without an object. Kay kung ni siya, dapat na po ni visualization. So if okay makita nga naglihok-lihok dira, why gamit ni siya? So naay object. However, naay mga misconceptions day for the object. An object can be either a particle or a body. No? So if dili ta mag-study ani, nay uban mo gamit interchangeably. So ang uban mag-body na pod, uban particle. So unsa day kalihan ani nila. So in this picture, the earth revolves around the sun. So of course we want to study the movement of the earth, no? It's angular angular speed, no, with respect to the sun. So since the earth is very small compared to its path, no, very kuan kaayo, kanang wide kaayo ni iyahang kanang travelan. So we can assume that the earth is a point size, no, rather than a body, no. So pwede na tog magdrawing tag kuan ani, let's say for example this is the path, no, we can just assume na mo ni siyang earth, just a point size, no, meaning ato gineglect ang iyahang diameter. So maka-claim na ta ani nga this is a particle given that ang iyahang size is very small compared to its path. Meaning ana sa may significance niya na, sir. So at any location on the earth, no, since ato magi-ignore ang iyahang dimension, meaning ang rotational speed, no, sa Canada o sa Pilipinas with respect to the sun is the same, parehara, because ato man siya gi-assume nga tanan nga naa sa earth naa ni nga point. Okay, now if we treat this one as a body, then maglahi-lahi na ay kalahian, no, pero kay mao man tungod kay very wide kaayo ang path nga travelan sa earth compared sa iyang size, then we can consider this one as a particle. Now on the right side, we have here on earth, exaggerate ra ang size sa human diri just to give kuan emphasis. So the earth where a man is standing is considered a body due to its appreciable size. So if the situation here is that if a man, no, travels from one place to the other along the earth's surface, then we can consider that the earth relative to the man is a body of appreciable size. Okay? Di na siya pwede mahimog point because dako na si earth with respect sa dimension sa tao. So mao nang gi-considered na siya as a body. Now, since these two concepts can be interchanged, no? So pwede pod nga si man with respect to the earth, due to the fact na gamay kay ang tao relative sa size sa earth, we can also say that the man is a particle relative to the earth. Okay? But if we do the reverse, so can say that the earth is a body relative to a man. Okay? So therefore, a body is an entity with noticeable dimension and is comprises of particles. Okay? So kaning earth, we have a particle here, pwede diri dira. So ato na siya combine, mahimo na siya body with noticeable dimension. Okay? So naay pangutana so far? Kasunod ra? Okay, so let's move on to kinematics versus kinetics. So these two concepts are the subfields of dynamics or sub-branches of dynamics. So again, from engineering mechanics, from mechanics divided into two. So we are now through with statics and the other one is dynamics. Now dynamics can be further divided into two disciplines. We have kinematics and kinetics. Starting with kinematics is Again, study of motion, but the key word here is without considering the effect of external forces. So we neglect the forces that interacts the particle, no. Ang ato ra after is ang iyang velocity, iyang acceleration, and iyang displacement. One good example of this one is the projectile motion. So here, we do not consider, no, we neglect air resistance because that is one of its assumption, ideal condition. We also neglect the mass of the particle here because we're only concerned with its velocity. So walay gamit ng mag FBD ka, imo i-sum up yung mga forces nga nag-interact sa usa ka particle, no, nga ni-travel in a projectile motion. That is kinematics. Okay? Mo na siya. Very simple, no, nga mathematical model to represent the motion of an object. Now, on the other hand, kinetics is the opposite of kinematics. So, it studies the motion of an object by considering the effect of external forces. There are some cases gid nga we need to take into account the external forces that interacts our particle or our object. As you can see in this figure, so we have here a particle color in orange, no? So naay mga forces nga nag-interact niya. We have the weight and the drag force FD. So ato ni siya i-discuss further on the later part of dynamics. So these two forces of course influence the velocity of our object as it falls downward. So with this, naano siya under kinetics. But kung inyo makita, since na may mga velocities diri so there are some problems in kinetics that also requires the knowledge of kinematics. But again, for kinematics, it does not require the knowledge of kinetics because it only deals with the study of the object's motion without considering the effect of external forces. Now, next, proceed ta, no? Kay since ang lesson 1 is more or less general concepts man. So let's move on to the second lesson for principles of dynamics. This is the second and the last lesson for this. Let's just call this one as first chapter, no? Chapter 1. So for the final lesson for chapter 1, we talk about motion of a particle. But introductory part lang. So just an introduction. So by the end of this lesson, you will be able to understand the concepts of these three important parameters: displacement, velocity, acceleration. Unsa kani sila nga mga butanga. Number 2, understand the three laws of motion. So we all know that Sir Isaac Newton contributed lots of um, ideas, no, and knowledge to dynamics, and one of this is his famous three laws of motion. Number 3, we're going to apply this a new principle, no, the Albert's principle in quantifying the kinetic equation of a particle. So let's start with the motion. Let's start with the three important parameters in dynamics. So in order for us to know the behavior of a particle, so we need to understand these three: displacement, velocity, and acceleration. So why do we need to know these three? Take for example this picture. So it shows a space shuttle, no, nga ni take off sa Earth's surface. So kani siya, this is a remarkable um, milestone nga na-achieve sa humankind. With this, naka-explore ta, no, sa kanang kwan, sa ato ang universe o sa atong outer space and other planets. Of course, di na siya mahimo without this knowledge in dynamics. So in order for the organizer, or shall we say the scientist, no, to predict the behavior of the space shuttle, no? Kailangan ni siya i-monitor, critical ang pag-monitor ni ani so that um the passenger or kinsa may naa ni sakay dira mga payloads will be on safe hand. So first is they want to know no kung asa na siya. This is the first thing no, first information nga ilang gusto makuha. Okay, unsa na may altitude sa ato ang space shuttle. So altitude indicates the displacement of the shuttle relative to the ground. Manay una, so pasok si displacement. With this, makaiba na siya, okay, ni-escape na di si shuttle sa ato ang Earth's atmosphere. Next, of course, they want to know the velocity. Now, why velocity is very important? It's because no, this space shuttle has a requirement. Kailangan ang iyahang take-off velocity should be greater than or equal to the escape velocity of the Earth because if it falls behind the escape velocity, magiging tawag escape velocity para maka-escapo ka sa Earth's gravity na if di ka maka-achieve ana, no? Di mo matapangan, then di ta makagawas sa Earth's surface or Earth's gravitational field. So we cannot explore the other planets. Kailangan ilan ni gid siya i-monitor. And also of course, lastly the acceleration. So how fast does its velocity changing? So why do we need acceleration? Why is acceleration a part of the three important parameters? It's because in a natural scenario, no, once the engine starts in a space shuttle, di man na siya maingon nga mokalit din na siya og kuan kanang iya velocity og ka 1,000 or 500 kilometers per hour. Di na siya yana no. Dili na siya ingon nga abrupt, gradual gina siya. So if the take-off of this space shuttle happens gradually, then acceleration will kanang come in, no? So dako na siya og roll kay iya ni i-track, no? Kung how fast this space shuttle changes its speed or velocity. Okay, so let's start with displacement. Now, as you can see in the figure, we have points A and B. Let's assume that point A is your initial position and point B is your final position. So you traverse or you travel no along these blue hidden lines, no? Paliko-liko ka. So let's differentiate between these two words. Mo gani sila medyo libog no. Napay uban ani maglibog pa. So when we say distance, this is the total length being covered while traversing. So kanang indicate sa blue hidden lines. Now, when we say displacement, this is more or less very important in dynamics. Displacement is different from distance because displacement is a vector quantity while distance is just a scalar quantity. Meaning displacement has a value and a direction. So displacement is the shortest distance from your final position to your initial position. So take a look at the huge difference. Distance here is greater than displacement, no? Displacement is just the shortest distance from your final position towards your initial position. Simple as that. But of course, there are some cases that your distance, no, will be equal to your displacement. Kung ang imong gitraverse is ang shortest distance. Okay? Again, displacement is a vector quantity, distance is scalar. Now let's proceed to these two principles. First, this one, so displacement and position vector. When we talk about displacement vector, it is a straight line that connects the final and initial positions of a particle. Para di maglibog, let's have the figure below. So this one, labeled as Px sub 1 y1, this is your initial position. And this Q here, no, represented by this x and y coordinate system, this is your final position. Now, our displacement vector here is represented by this red arrow. So it connects your initial position and your final position. And in other words, or in symbol, girepresent na siya by delta R. Okay? Delta R bar. So that is equal, no? Simply equal to the what? Kani siyang ato ang R1 or mag-una ta R2 minus R1. Okay. Or in other representation, no? Basta kay alang kalimti displacement mostly gi-represent man na siya by change in x. So yung muna ko nga that is x final minus x initial. Simple as that. Okay. Now, dito sa position vector. So position vector, it locates the position of a particle with respect to a given frame of reference. So since displacement is a vector quantity, of course, we need to know its direction. So one way of telling the direction of your position is by plotting it in the x-y axis. In that way, makaibaw na ka sa iyahang direction. Okay? Because coordinates is one of the method in determining the position. So the position vector here, we have two. We have position vector r1 prime and position vector R2 kaning naay murag kan symbol sa top part. So ang position vector dili na siya ingon nga with respect always to the origin. So it depends upon your frame of reference. Let's proceed to velocity. So again, displacement, that is the shortest distance. Now for velocity, we have two important kuan pod no mga concepts nga medyo maglibog ang mga students. So first is average velocity. When we say velocity, that is a vector quantity, no? So average velocity ato represent by v average. That is the ratio of the displacement, no? In the given figure, we have d over the total time, or in terms of x and y coordinate system, that is delta x over delta t. Okay, the total time of travel. So again, do not use distance when solving average velocity because that is velocity. However, for average speed, ato lang i-denote nga s, okay, average is equal to the total distance traveled, no? Kani siya kaning red hidden lines. So ato lang siya represent as small letter d over the total time of traveled, or ato spell out, no? Total distance traveled over the total time. Total time of travel. So manay kalahian sa duha. Now we also have instantaneous velocity. As you can see on the graph, we have here the graph of position or the displacement versus time. So the slope of the position versus time graph, no, tells us the velocity. Or if that is a curve, it tells us the instantaneous velocity. Pasabot aning instantaneous, that is the velocity at a particular time. Now, sa ato mga figures, that is a straight line. Now, if we have this complex curve of our displacement and time, no, pasabot na instantaneous. Now, if we have a curve by using differential, of course, we can predict its slope. So the slope is the perpendicular line, no, nga tangent sa ato ang curve. So with that information, no, we can predict the velocity at any point or at a particular point. And that kind of velocity, we call that one as the instantaneous velocity. So in symbol, ato laikuan nga v, that is equal to, that is change in x over change in time, or that is velocity is equal to the limit, no, as delta t approaches 0 of delta x over delta t. simply mo na siya ang derivative, no? Derivative of the given curve for position and time graph. Now, proceed ta sa acceleration. Okay, by the way, balik ta sa displacement. Ako lang idagdag ang possible units, no? So, for displacement, since length naman siya, so expected ani nga mga kuan, expected nga mga kanang unit ani kay for English we have meter, inch, we have foot. Okay. Now for our velocity, that is length per time. So therefore we have meter per second, we have feet per second, no? Or we have, let's say, inch per minute. We also have kilometers per hour, or that is kph. Now, moving forward for acceleration, so we also have the average acceleration. So represented by A, ave. So average acceleration is just the ratio of the change in velocity. So delta V kay change man over change in time. Now, by looking at the formula, that is velocity per time. Velocity per time. So, unit analysis, velocity is meter per second. Example na siya. Of time is second. So, therefore, acceleration is length per time squared. Or, you can have inch per second squared or feet per second squared. Man siya expected nga mga dimensions for acceleration. Now, when we talk about acceleration, nga po tayo instantaneous acceleration. Because if we plot velocity, no, unlike sa velocity nga, ang plot nga to kay position versus time. Now, for acceleration, we also have a separate separate graph. So, we also plot velocity and time. So, the curve natin ma-generate ana, and the derivative of that curve tells us the acceleration. Again, acceleration instantaneous is equal to the first derivative of velocity, so that is delta v over delta t, no? Or equal po na siya sa second derivative daw sa displacement, because we all know that velocity, no? Velocity is displacement over time. So that is dx squared over dt squared. Again, velocity, first derivative niya with respect to displacement, while acceleration is second derivative with respect to the displacement. Okay, ato na siya i-expand further ning sa average, no? That is V final minus initial divided by T final minus T initial. Ano pasabutan ng change. Okay, so we're going to use these concepts, no, in solving some sample problems. But before that, ato po din include ang analysis on displacement and velocity graphs. So common gid ni sa dynamics, no, kaning mga graphs. So diri ato siya ipang-interpret if hatagan ta og mga graphs. So here mag-label ta sa tano para di ta maglibog. So we have this horizontal line number 1, naatay slant line 2, another positive slant line 3, tapos 4, 5, 6, we have 7, we have 8. So starting with the first one, okay? Sa may atong interpretation, ana, remember that our x is the position or the displacement and our y or the horizontal is the time. Now at first, as the time increases from 0 to 1, sa may position niya na, di ba 0? So meaning, at rest siya, no? At rest. Kay constant man ang position. So naghunong na siya. Now for the second one, ay a position kay negative. So since ang atong displacement is a vector quantity, if we have a negative displacement, pasabot ana no, negative displacement pasabot ana niatras ta, okay, or that is opposite sa ato ang kuan motion. So traveling in opposite direction. Okay? Kay negative man ato ang values tong position. Number 3, nisaka na pud siya. So bali, no? From 2, travel na pod, travel in opposite direction. Now, how about its velocity? We all know that uh, the velocity here is the slope of the graph. So sa number 2, the slope here is negative. So that is why we have a negative velocity. Now for number 3, positive ang kaning iyahang slant. So therefore we have a positive velocity. Okay? Now kaning sa number 1 sir at rest, we have velocity 0. Continue with number 4. Diri ana pod nihunong na pod siya because the position is constant, no? Horizontal man ang line. So at rest na pod siya, no? At rest. That is velocity na pod dira equal to 0. For number 5, same with number 2. So same with number 2. But of course, greater magnitude lang kay pataas na iyang na ano, slope niya. Number 6, same gihapon, same ni 3. Same with number 3. Bali positive ya velocity. For 7, at rest na pod. No, at rest. And for number 8, same with number 3, no? Pero ni-return siya siyang original position. So return to original position. Kaya nga naman, tungod kay nag-start siya at 0 nga position, ni-end siya at 0 position. So ni-return siya sa iyang original nga position. So this is how we're going to interpret displacement versus time graph. So again, ang slope sa displacement versus time graph is the velocity. So we also have velocity time graphs, no? Napunta ka to kaganiha displacement to siya. So move taning velocity time graphs. So we have first, second, third, and fourth. Now, if the velocity time graph, if paingani gay siya, no, again, the slope of this one is equal to the acceleration. So, pasabot po ani, nag-increase atong velocity at i-constant rate. So, pasabot ana, increase velocity at constant acceleration. So, acceleration here is positive. Number 2. Pag number 2, kuha na siya. Constant yung velocity. Meaning, it travels at a constant rate, no? Constant velocity, zero acceleration. Now for number 3, you manotice ang slope is negative, no? Slope is negative, so bali ang ato ang velocity ingon sa man decreases. So velocity decreases, nag-negative. Pasabot ana ang ato ang acceleration, no? Decreases. Meaning nihinay siya, decelerate. Okay? So negative man ang slope ana niya. Now for number 4, so velocity na pod ni increase na pod siya ginahinay. But nagyapon siya sa negative part, no? So velocity increases niya ato ang acceleration pod ni increase pod siya. Okay? So ana. Imo na tan-awon ang slope, no? If paslanting kay siya towards the right, so positive slope na siya, meaning velocity increases, ang acceleration pod ni increase. So again, ang take away nako diri ang part is that the slope of the velocity time graph is the acceleration of our object or our particle. However, for displacement versus time graph, the slope here indicates the velocity. So let's have our first problem. So here states that a man walks 20 meters north. Ato na siya i-kano. So 20 meters north daw siya. This is 20 meters. Tapos 14 minutes. Next, 15 meters east. So padong dito ana. So this is 15 meters. 11 minutes ang iyahang time nga pag-travel ani. And then we have 10 meters southwest. So when we say southwest, that is 45 degrees pa south ya west pa gyud, so nga ni siya. So this is 45 degrees. This is 10 meters for 8 minutes. Okay, so again, this is your starting point A. This is your ending point B, or your destination. So ang required ani, we're going to solve for the distance traveled. So ato la i-represent as D, distance. Kaduha, displacement, so delta x lang, displacement. Average speed, so S ave. And then average velocity, so that is V average. Now let's start with the distance. For the distance, remember, i-add nimo ang mga distances ngayon na-cover. So sa first part sa trip, 20 meters north. Second part sa trip, 15 meters, so 15. Third part, we have that is 10 meters. Okay. So i-add ra, we have 20 plus 30 plus 15, so we have 45 meters. Okay. So mo na siya ang distance nga iyahang na-cover. Now for displacement, no, that is initial position, no, minus final position. So kani. So pila ka high kuan ana. Now for your displacement, actually you can use a summation of vectors, no, along the vertical and also along the horizontal, just like what we did on the forces. So let's say for example, kay kanitong ipangita nga displacement ha, delta x. Okay. So summation of, let's say, displacement lang along the vertical, pila man kana siya. So natay 20 meters pa north, so positive kung pataas, so we have 20. Now the last vector kaning 10 meters southwest, that is negative. So ang iyahang vertical component kay kani siya, no, kani. So that is minus 10, that is sine 45 degrees. So pila may iyang resulting niya nga displacement vector, so 20 minus 10 sine of 45. So we have 12.93, approximately 12.93. that is meters. Now, summation forces along horizontal. So, positive ning padong east. So, we have 15. Now, pa southwest man So, pabali. So, minus 10. That is cosine 45 degrees. Ang iyahang horizontal component aning final vector. Remember, we have three vectors here. Vector 1 pa north, vector 2 pa east, vector 3 pa southwest. Simplifying this, so we have 15 minus 10 cosine 45. So we have 7.93. So 7.93, that is in meters. So solving for the displacement, no, delta x is just equal to the square root of summation of x ni siya dili force, squared plus summation of x horizontal squared. Okay. So ato siya isolve. Now square root of 12.93 square plus 7.93 square. So we have 15.17. So 15.17 meters. So that is the distance, no, shortest distance from your initial position to your final position. Now, since this is displacement, no, this is just the magnitude na ato nakuha. For its direction, so using tangent, no, so unsa may theta ani with respect to the horizontal, no, what would be its theta? So theta is simply arctangent lang, di ba? Arctangent of the component vector along y. So y is the vertical. So summation x vertical over summation x horizontal. Okay? So just take the absolute anyways. Let's interpret kung unsay pasabot ano mga negative sa vertical ug sa horizontal. So shift tangent for the arctan. So xv is 12.93 divided by 7.93. So we have 58.48. So 58.48 degrees. That is north of east, no? North of east. So mo na siya ang iyahang direction, no? Mao na siya, mao man ni ang angle nato. Because why is it nga naa man diri no? Kung ato na siya ikon sa quadrant, no? Nganong naman sa quadrant 1 dapit sir? It's because ang ato ang values for vector vertical and vector horizontal are both positive. So kung positive gina ang mga values na siya sa quadrant 1. So manang north of east ang designation na because this is north, south, this is east, this is west. So that is north of east na siya. Here is our theta. Okay, naipangutana ni kaning distance of displacement. See the difference, no? Naagid sila'y kalahian. Mas dakog value ang distance. I think na may nag-comment. Si Mateo. Sige, go ahead, Mateo.
Sir, question sir sa answer ba sa asa gikan ang kanang 45 degrees nga sa kanang angle na putol.
Okay, ang 45 degrees mo na siya ang interpretation sa southwest nga word. Diba? Sa ato ang koan, we have north, this is 90 degrees, east 0 degrees, west 180, south is 270. So kanang in between sa north ug east, that is northeast. So in between sa 0 ug 90, that is 45. Okay? Oo, but that is southwest, so opposite diri ana diri. So nade ang 45. This is southwest. Okay? So, walay pangutana?
Sige, sir.
Okay, example number 2. So, a car can travel from A to B a distance of 100 kilometers at an average speed of 30 kph. At what average speed must it travel back from B to A in order to have an average speed of 45 kilometers per hour from the round trip of 200 kilometers? So, ang scenario ani is that we have point A, point B, the distance of this kanang kuan, these two positions is 100 kilometers. Now, ni-travel siya from A to B, no, at an average speed. So, dito na siya S average 1 lang ato indicate, that is 30 kph. Sunod, ang ipangita di ay ani is ang average speed niya pagbalik, no? Balik siya. That is S ave 2. Kung nagipangita. So that naa siya'y unsa man, naa siya'y average speed total, no? So naa siya'y S average total of 45 kilometers per hour. So pasabot ang round trip nga 200, meaning pagpadunga to 100, pagpauli another 100. So ang total distance, no? Total distance for the entire trip is 200 kilometers. Now, ayaw ka ano, basig ang inyong buhaton ani is since this is average speed, basig ang inyong kuan ani, ang solution ninyo no is paingani. So the average speed total is equal to the first average pagpadungad to plus ang average pagpauli divide by 2 kay average man. So wrong ni siya nga pamaagi. Kailangan gamiton to ninyo ato ang principle ang gi-explain sa inyo. Remember that the total average speed kung mogamit ta ani kailangan coherent ta sa ato ang definition. So that is total distance traveled kailangan. So total distance nga na-traveled all over dapat total pod nga time. So total time. Now, given matag total distance, no? 200 kilometers. Ang problema ang total time. Pero kay ba man ta nga ang total time, no? But ang atong total time is equal to ang time pag A to B plus pagbalik niya. So, time from B to A. Now, ang time from A to B actually can be solved using sa speed formula, no? So that is distance, first distance nato all over the average speed. Okay. Now, for T2. So T2, same thing gihapon pagbalik dito all over S average ikaduha. We all know that D1 is equal to D2, which is equal to 100 kilometers. Okay. Now substitute this one. So we have S average total equal to the total distance, that is 200 all over. So we have T1, no, T1 is D1, that is 100 over the average speed sa first is 30 kph. Now, wala lang ko isuwat ang mga units kay kuan man sila kanang coherent sila. Ang distance nato is in kilometers. So ang atong speed kph. So expected nga hours ang gawas ani for the time. So that is plus 100 gihapon and then mo na atong gipangita. S average 2. Okay? So required S average 2. Okay. So this one, again, this is equal to the total average speed, that is 45 kilometers per hour. Now, we can solve the average speed, no, directly. I will teach you the kuan, shift solve. So since usa ra may gipangita unknown, madani siya shift solve. So ingani ang pag shift solve, imo siya na siya i-type. So we have 200 tapos 100 divide by 30 plus 100 divide by average speed mo na ang unknown. So alpha x. So alpha tapos press x tapos alpha press calc for the equal sign tapos type 45. So to execute shift solve, so shift lang kani, shift tapos calc na may solve dira ang nakabutang. So calc equal, so the result is 90. So therefore ang average speed day pagpaulit nimo is 90 kilometers per hour. Okay? If you use this wrong formula, lahi ang magawas na dili 90 kilometers per hour. The exact answer is 90 kilometers per hour. So don't forget total distance traveled over total time of traveled. Okay, naipangutan na? Wala. So proceed ta, number 3. Explain daw the displacement versus time graph below and provide its corresponding velocity versus time graph. So pareha sa ato ang gibuhat kaganiha, ato na butangan og number, no? So number 1, number 2, number 3, tapos we have number 4. So sa first nato, again, since this is displacement versus time, so at t equals 0 to 1, unsa man iyahang behavior sa iyahang displacement or position? Steady lang, okay? Horizontal. So 20 gihapon. So displacement is 20. Sorry, the delta x is 20, meaning at rest. Okay? At rest. Wala siya naglihok at that position nga 20 meters from a reference point, no? Kaduha. So sa pagkaduha na, imo pud manotice sa ato ang graph. So ang number 2, this is a line that has a positive slope. Bali ani ni-increase ang iyahang position with respect to time, therefore na siya constant nga velocity. So constant velocity. Nganong constant? Because the slope of the position versus time graph is the velocity. So straight line, naray usa ka slope. So moving. Now number 3, pag abot sa number 3, niabot na siya og 60 meters ang displacement relative to our origin. Nihunong siya because steady man, no? Steady a position. Around 3 to 4.5 seconds. Steady siya. So again, displacement nato as now is 60 meters. Tapos at rest na pod. Okay, nipahuway siguro na siya. Number 4. Number 4, so gikan 60, kayo makita, uy, ni drop ya displacement from 60 to 20. So yun hitabuan ni. Meaning nibalik siya, no? Nibalik siya. So ni kuan siya, ni change ya direction, no? So change direction. Unya pasabot pod, other interpretation ani, the slope of the line 4 is negative, therefore we have constant negative velocity. Moving gihapon siya. Again, when we have a negative velocity, indication ana ni change ra ka og direction. Ni change ra ka direction. Ni balik ka sa imong gikanan. Okay? So, this is how we're going to interpret the position time graph. Next nato is provide daw corresponding velocity versus time graph. So, this is position time graph. So, kailangan kay bago ta mohatag og interpretation ni ani sa velocity niya. That is meter per second. Tapos, we have time that is in seconds. So, ang mga kuan lang, known lang ang mga boundaries sa to i-draw diri So, number 3. Tapos, 4.5. And lastly, we have 6. Now, this is velocity already. So, ang ato buhaton at from 0 to 1 second, nag-steady lang siya, no? So, pasabot ana, wala tay velocity. So, 0. Kani akong gi-crash. Muna na ito ikuan para ma-emphasize. Now, from 1 to 3, from T1 to T3, na siya constant velocity. Now, if we're going to solve that one now using our average velocity, that is V final minus V initial divided by T final minus T initial. Okay, so naatay V final nga 60, na V initial nga 20 divided by 3 final minus 1, that is the time. So ato na ma-solve ang 13.33 meters per second. So that is the velocity nga iyang gi-maintain from 20 meters to 60 meters nga displacement. So ato na i-graph actually after 1 second yun, no? Kalit dayon naka-maintain siya og constant velocity from 1 to 3. So ayan na anara. Okay, so this is 13.33 meter per second. Mo niya iya gi-maintain from 1 to 3. Next, from 3 to 4, ni 0 na po diya velocity. So, down na po din ka. Ni down siya, ni balik og 0 kay ni at rest naman po. From 3 to 4.5. Next, from 4 to 6, no? Nag-negative iya velocity. Okay? So, pasabutan, ni balik siya. So, if negative, nanas ubos. So, atalayan na negative na nga part. Nya padong siya og 6. Okay. So, may value ano niya. So, use this one gihapon. So, V average, again, V final minus V initial divided by T final minus T initial. Final velocity, okay, sorry, this is not V final, sorry. This is displacement, sorry This is not velocity. That is displacement. So, X final, X initial, X final, X initial. So, final nga displacement kay 20. Initial displacement kay 60. Final time is 6. Initial time kay 4.5. Now, kung ato ni i-compute, ang answer kay, so, gamit ang calcu, 20 minus 60 divide by 6 minus 4.5. So, the answer is negative 26.667 meter per second. So, nas ubos na. Negative 26.667. Okay? So, mo ni siya ang ato ang pag-create og ihang corresponding velocity time nga graph. So, naay pangutana so far? Any question? Tara. Okay. So, next ani, we have the three laws of motion. So, first one is we have the kanang law of inertia. So diri inyo makita sa figure. Again, this is just a review, no? So if ang object remains at rest, will remain at rest if way mga outside interferences. That is a static condition. Now naapod tay dynamic condition. So mo continue na po na siya og move at constant velocity, meaning wala ni change ang velocity, we have zero acceleration if walay mga external forces nga ni-interact sa iya, meaning wala niluhag ba. Okay? In layman's term, wala niluhag niya. If ever ni kuha na siya, ni move at constant velocity, wala nagluhag-luhag niya, way mga friction nga present, then it will continue to move forever. So manay first law. For second law, it talks about the law of acceleration. Bali, it relates the force, no, to the mass of the object and its acceleration. So if massive ka, no, gamay kay kag acceleration, bugat naman ka so maglisod kag lihok. Now if gaan ka, so paspas yung pagdagan, no, mo accelerate dayon ka. Now if magdungan ang imong mass, bugat kay ka unya napigig kay power to accelerate more, then dako kay kag force nga i-exert niya na. This is second law of motion. Okay? So meaning iyang gi relate ang acceleration sa force o sa mass. Ang third law of motion mo na siya ang law of interaction. So mao nang sa ato ang review sa statics, no, na ay block na nakastay sa ka surface. Syempre wa na siya mahug padung ubos tungod kay ang iyang weight gi-exert sa surface through the normal force. Okay? And again, normal force here is equal to the weight. No? So naay reaction and naay action o reaction. So natay weight gi-react, no, or gi-counteract ni normal force. So mana siya ang Newton's three laws of motion. Next, diri ata sa D'Alembert's principle. So final na siya. So again, don't worry, ato na siya i-explain further sa next nga chapter kani siya ang concept ng ani. So pasabot ani nga principle daw, the resultant of the impressed forces acting on a body is equivalent to the vector sum of the effective forces acting on all the particles composing the body. So for a moving body, this resultant is equal to the product of its mass and acceleration, which is being defined at its center of gravity. Say for example, we have here a blue block gani rest at the surface, no? So let's say we have effective forces, no? When we say effective forces, mo na siya ng forces nga nag-interact sa to ang block. Now, block here is considered as a body given nga na siya length og width, no? So ang first nga effective force P1 ni-act si ani nga part lang. Okay? So diri mindful na kay ta kung asa gid ni-act ang mga effective forces. So kani nga portion sa gi-act ni P1 na ay particle diri So kanina nga particle ang naigo, no? And also P2 this one. Okay? So manang ingon siya, oh, vector sum of the effective forces acting on all particles. So what else? On the horizontal natay, I mean the vertical natay weight syempre. So weight from the center of gravity and also the normal force asa ikan ang normal force diri sa surface nga nipilit. So i-sum up na ang mga force nga nag-interact sa kaning particle 1, particle 2, particle 3, particle 4, no? Given nga dako kayo ni og value ang mga effective forces, ato assume nga mo-move ni siya ang block towards the right, this is the direction of motion, and also naay friction nga interact given nga ideal ni siya, I mean actual ni nga surface. So naay friction nga ni act ani sa surface, no? So naay mga particles na sa surface. Ato na siya i-sum up, no? So summation forces lang, summation forces horizontal by the D'Alembert's principle, tanang mga forces nga i-sum up that is equivalent to the mass of the object times iyahang acceleration. So that is mass times acceleration. So taking positive kung pa-right, so we have P1 plus P2 minus frictional force is equal to mass times acceleration. So inganiyon nato pag-define ang ato ang equation of motion using the Allenbert's principle. Now, magamit din nato sa next chapter wherein we're going to solve the kanang kuan, the kinetics of a particle, no, with external forces nga nag-interact sa iya. So any questions so far before we end? Okay, wala. So ako lang i-stop ang record.